Okay, so I am joined with Andrew here and showing him just a quick run through of the resources I've made for geodesic domes. So just starting with, I have my physical model, which unfortunately I don't have with me, but I've taken a series of pictures of it. So Andrew, the whole idea behind this kind of resource is to show students who are struggling with visualization of a geodesic dome of what the actual end product is meant to look like. So I made this using small rolled up pieces of paper and just masking tape. I decided to make it so I'd have it as a kind of a resource to show students and so I'd understand if I wanted to make it with students someday. Secondly, I've just drawn up, because resource or rotation about a point is a key principle of the geodesic domes. I've just done a quick little step by step of how to rotate an object about a center point. Moving on, I have a SolidWorks resource of the octahedral geodesic dome. So this is just kind of to show students kind of how you start off your drawing of the first segment of your plan. Moving on to the solution. So as you can see, I brought in the rotation about a point where all the points are projected from the center point left onto the next quadrant. And it can show students how to project up into plan and elevation from your edge view. Then I have the icosahedron method, where it's the same principles behind it, except we use a pentagon instead of a square to start. And just looking at the solution to it, we can see the same principles of the rotation about a point.
Yeah, I think it's a great way. It's great to show the actual physical source, so you can actually show the students the end product of the geodesic dome. But why is it so important to show the two methods?
So I used the two different methods because just looking at, for example, the question which I've designed, you can see that students are asked to construct something like for in this case it's a greenhouse, so all areas would have to be flat on the ground. So as you can see from the solution of the octahedral method, all points are flat when touching the ground, whereas in comparison to the icosahedral method, there are some points that are not touching the surface of the ground. And other than